All right, everybody, and on to 8.2. This is the cosine law. The cosine law is typically used in acute triangles. Again, similar to the sine law. However, notice the formula previously. Sine law, sine was used. In the cosine law, cos is going to be used. So these are non-right angle triangles. However, you can use the sine law and the cosine law in right triangles, but they're a little bit more in-depth calculation. So it's usually easier if we just use SOHCAHTOA. So the different cases we can use sine law for are as follows. One of them would be 3 side lengths. So if there's a triangle, that would mean you are given all 3 sides. The other case is when you're given 2 side lengths and 1 angle, but the angle must be enclosed by the sides. So that would be this angle in here. Because if you think about it, if we use the opposite one over here, a different angle, this angle is opposite a side length, and we said anytime you have a side with its opposite angle, you would use sine law. So the angle must be enclosed by the 2 given sides in order to use the sine law. So here are the 2 equations, depending on which one you're looking for. Again, you would label the triangles exactly the same, A, B, C, and the opposite sides would be lowercase letters, just like in the sine law. And so depending on which you're looking for would depend which formula you use. However, they're exactly the same. Notice that the lowercase a for the side length is what matches with the angle in the cos. And then the other remaining side lengths would be the b's time and the c, and then that's what gets multiplied by the 2. Likewise with the opposite formula here. So in this example, the first example here, we're looking for the distance between the lighthouse and the rock. So we're looking for this here. So first you always want to label your triangle. So A, B, C. Again, it doesn't matter if I could have done A, B, C in a different order as long as you label the opposite sides with what's there. So this B opposite side would be over here, lowercase c opposite side over here. So if you're looking at which one we're looking for, we are looking for A. And if you go back to the equation, we have A here. Now, anytime you write this formula, it doesn't have to be ABC. It can be whatever letters the triangle is labeled, and you would just write the equation accordingly. So our equation is A squared equals B squared plus C squared minus 2, and then times those as well, and then times cos A. So if we start subbing in values, we don't know what the lowercase a is. We do know that B is 4.2 squared, and we do know that C is 4.5, and we must square it. And then it's minus the 2 times the B, which is 4.2, times the C, which 4.5, cos. We do know angle A. That's right here. So we have cos 26. So if you follow your bed mass, you'd have to do all the exponents first, and you'd have to multiply this. And so we would have then 17.64 plus 20.25 minus 37.8, and then we'd leave as cos 26, because remember, we never want to put this in until the end, as like we said before, the decimals. We want to keep it as accurate as possible. So if we add those two, that's 0.89. That would be, again, 37.8 cos 26. Now, a common mistake that happens here is that these, for example, get added. You cannot do that. Remember, this is multiplication. So this has to happen before you can bring those like terms together. So this would be a squared, and it's about 3.91558. Now I've put cos in. However, on my calculator, I left it all there the entire time. And so you take the square root of both sides, and you get a to be approximately 1.98. So notice that I wrote down what it would be, but I kept all the decimals in my calculator. So just always make sure that when you're doing this, that you're following your bed mass. Make sure you have your therefore statement as well at the end. So in example 2, here we'd have to draw our diagram, and it's different letters. So we have D, E, F, and so this one will be lowercase e, F, and D. And so we can say all these measurements, 21, E is 18, and this one is 17. So how do we know which formula? You could write all 3 formulas out, but then you want to go back to which one are we looking for? We are looking for angle D. And remember that the angle here always corresponds with the letter that's in front. So if we're looking for angle D, that means our equation has to be D squared equals E squared plus F squared. Because we're looking for angle D, we would use the formula that has the D in front. And then we would write the rest, and it would be for cos of D. And then we just sub in our values. So we have 21 squared equals 18 squared plus 17 squared minus 2 times 18, 17, and then cos d. So this is the example where we're given the 3 side lengths. And so now, again, we're trying to solve for d. So we have to move everything to the other side. So first I'm going to move this here. So we're going to go minus 18 squared and minus 17 squared equals negative 2 times 18 times 17 cos d. And so this can be simplified on this side to negative 172 equals negative 2 times 18 times 17, which 2 times 18 times 17, that could also have been multiplied. We'll just leave it as is. This is going to have to go to the other side because we're trying to get d by itself. So we divide it by the negative 2 times 18 times 17. We do that on both sides times 18 times 17. And notice the only thing left on this side is cos d. So if we're trying to get d by itself, we have to move cos to the other side, and we would have to do cos inverse of everything that was right there. And if you type that whole thing into your calculator, you would get that d is approximately 74 degrees. So if you have any questions about this one on how to solve it, remember you're trying to get d by itself. So you have to peel the pieces away that you can first. So if you have questions, make sure you write them down and bring them to class. See you in class. Bye.